Hello. In this video, I'll show you some information about argon dating and the Hawaiian Islands. The Hawaiian Islands are part of a mountain chain that formed over millions of years by a hotspot and moving plate process. The hotspot is relatively stationary and pushes enough material to the surface to produce mountain chains, which become islands. The motion of the ocean floor carries these islands sideways so that new islands are formed. The direction of the ocean floor motion is about 30 degrees north of due west, which means that the eastern islands are newer and the western islands are older. The island heights and sizes are good evidence for the hotspot and moving plate process. In addition to having larger areas, the eastern islands are also much taller than the western islands, which you can see in this graph. In addition, the eruption history is consistent with a hotspot and moving plate process, since only the two easternmost islands have had eruptions since the islands have had human residence. GPS devices provide additional evidence. The same methods that people use to learn about the locations of their cars have been used to measure the locations of surface stations very accurately. By making many measurements over many years, the motions of the surface stations relative to each other have been determined. Here is a map showing the results of GPS measurements of many fixed locations all over the world for several years. It shows that the Hawaiian Islands are moving relative to other land locations in a direction about 30 degrees north of due west at a rate of about 7 centimeters per year. That direction is very similar to the direction of the mountain chain. Now I want to talk about argon dating, which is a method of determining the time at which events have happened in the past. It works because different isotopes behave differently. Many isotopes, such as argon-36, argon-38, argon-40, potassium-39, and potassium-41 are stable. The isotope potassium-40 is unstable and changes or decays into argon-40 and calcium-40 with a half-life of about 1.25 billion years. This means that for a typical rock which contains potassium-40 atoms, every year, a known fraction of these potassium-40 atoms changes into argon-40 atoms. Argon atoms are different from most atoms because they do not form strong bonds with other atoms. This causes them to move rapidly when they are heated. During volcanic eruptions, the material is typically heated enough that virtually all of the argon atoms move to the surfaces of the material and escape. Therefore, just after a rock is formed during a volcanic eruption, it contains a very, very small amount of argon. However, each year after that, some of the interior potassium atoms change or decay into argon atoms. Since the rock has cooled to a lower temperature, the argon atoms are no longer able to move around and escape, except for those which are very close to the rock's surface. As time passes, this argon accumulates inside the rock at a known rate. After measuring the amounts of argon-40 and potassium-40 present in a rock, scientists can then calculate the amount of time that has passed since the rock was last heated to a very high temperature. Argon dating has been performed on many rock samples from the Hawaiian Islands. This graph shows on the horizontal axis the longitude of the island where the sample was obtained. The vertical axis shows the time since the sample was last at a very high temperature, as measured by argon dating. We can use this kind of data to calculate the speed of the ocean floor over the last 30 million years. The result turns out to be about 9 centimeters per year, which is very consistent with the value of about 7 centimeters per year produced using GPS measurements. The direction is also consistent with GPS data and island height data, since it shows that the western islands have been cool for millions of years longer than the eastern islands. This consistency is strong evidence that the decay rate of potassium-40 atoms into argon-40 atoms has been constant for many millions of years. In addition to the Hawaiian island chain, the hotspot and moving plate process has produced many other mountain chains, such as the very linear Louisville Seamount chain, which is east of New Zealand. Just like the Hawaiian island chain, newer islands are located to the southeast. This trend has been confirmed by argon dating. Now I want to summarize the main points of this video. There is lots of evidence in the Hawaiian Islands and elsewhere supporting the hotspot and moving plate process for producing mountain chains. They include the island size differences, the eruption history, the direction and speed of the islands determined by GPS, and the direction and speed of the islands determined by Argon dating. All of this information is very important because it gives us confidence that Argon dating is a trustworthy method for learning about events that happened millions of years ago. This is important because Argon dating has been used to determine the age of many, many fossils, which have been useful for helping us understand evolution. Links to my sources are inside the video description. Thanks for watching.